Okay, now we're going to look at exponents with the quotient rule. So again, whenever you're dealing with exponents, you can always write it out the long way, but if you remember your rules, you can get through it a lot quicker. So if we do it the long way, we have a to the fifth, which means a times a times a times a times a over a cubed. Now we know that whenever we divide a number by itself or a letter by itself, we get 1. So these are going to cancel, these are going to cancel, and these are going to cancel. So we are just left with a squared. Now the quotient rule tells you that if you're dividing and you have the same base, you can subtract your exponents. So we could have also solved this problem as a to the 5 minus 3 and get a squared. So you get the same answer either way. So let's do this problem using the quotient rule. So you have r to the 4 divided by r to the 3. So we have r to the 4 minus 3, which is going to be r to the 1, which we just write as r because r to the 1 and r are saying the same thing. Basically, this is telling you that you have 1 r, which is obvious because there's 1 r written, so we don't have to write to the 1. But as we did before, we can actually write this problem out, and so you would have r times r times r times r divided by r times r times r. That gives you 1, that gives you 1, that gives you 1, and you are just left with r. Okay? For the next one, we're going to do it both ways. So let's do the long way first. So we have 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. And you are left with y squared. Or you have y to the 8 minus 6, which gives you y squared. Now, sometimes you'll have an example where your exponent will not be positive. Whenever you do that, whenever that happens, you want to make sure that you write your final answer as a positive exponent. So, for example, let's say we have z to the 7 over z to the 10. Okay, using our quotient rule, we know that this is z to the 7 minus 10, which is going to give us z to the negative 3. You don't want your final answer to have a negative exponent. So remember, we're going to put this under 1, or think of it as the reciprocal of z, which is going to be 1 over z. And then this 3 is going to become positive. So that's how you would write your final answer. Now with this problem, you can do it a couple of different ways, but using your exponent rule, your quotient rule, you're going to have 12 to the negative 7 minus a negative 6. Remember, if we have 2 minus signs, that makes a positive. So your final answer is going to be 12. Well, your next part is going to be 12 to the negative 1. We can't leave it as that negative, so we need to put it under 1 and do the reciprocal of 12. So we're going to have 1 over 12, and we could write 12 to the 1, but that's not necessary because, again, 12 to the 1 and 12 is the same thing. So your final answer is just going to be 1 over 12. Now for the last problem, we have x over 10 over y to the 7th. We cannot do anything with this because our bases are different. Notice our base is a for both of these, r, y, 12, and z. But for this, my base is x and my base is y. So I cannot combine them to simplify the exponents. So this is as simplified as that gets. All right, so that's the quotient rule. See you next time.